guys, so this is going to be section 5.1. It's about solving systems of linear equations with two variables, okay? So by that I mean I'm going to give you a system of equations which implies more than one equation, and I'm giving you more than one because I'm giving you two variables. So here's a hint: the number of equations you get depends on how many variables you have. So if you only have one variable, one's enough to solve it. If you have two variables, you need at least two equations to solve it. And if you have three variables, then you need at least three equations to solve it, and so on and so forth. Okay? So first let me start off by showing you what a system of two variable equations would look like. For example, 2x plus 6y equals 24, for example. And x plus 5y equals 3. So this is a system. It's two equations, not just one, each having two variables. Okay? So in this one, if I told you this point right here, point -3 and 5 is a solution, can you tell me if that's true or not? Without actually learning anything new yet, just by what you know already, can you tell me if this is an answer or not? Because looking at it, we know that we at least have two solutions because we have two different variables, right? X has to be some value and y has to be some value, and they're not necessarily the same. These two x's are the same though, so whatever value you have here is going to be the same one here, and these two y's are the same. I'm just saying x and y are not the same as each other. So when I gave you a point, I gave it to you as an ordered pair, meaning one of them is an x value, one of them is a y value, right? So you could easily plug them in and find the answer. So what we do here is plug them in to check if I plug in the -3 in here and the 5 in here, would it give me 24? And if I do that plug in here, would it give me 3? Make sense? That's how you solve for the system. So when I'm asking you to solve for the system, I need both equations to work, not just one. So let's try. Here we go. -3 in the first equation. So that's what? 2 times the -3 instead of the x, plus 6 times the 5 instead of the y, and it equals 24. Now 2 times -3 is what? -6, right? Plus, now 6 times 5 is 30. So when you add -6 to 30, that gives you positive 24. This is correct. We're good. Okay. So what about the second one? Plug in the -3. Let me draw a line. Plug in the -3 plus 5 times the other 5 equal 3. Okay. So 5 times 5 is what? 25, correct? So when you add -3 to 25, that gives you what? A total of positive 22. And obviously 22 is not 3. Therefore, this one is incorrect. Since one's right, one's wrong, that means the answer is no. This point is not a solution. Make sense? So it has to work for both. Let me give you another example. How about... Oh, let me give you a few seconds here. 1, 2... Okay. How about this one? If I gave you this system, 5x plus 10y, and it equals 5. Okay? And the other one is 22x, oops, sorry, it's minus 6y, and it equals -3. So this is your system. Two equations with two variables. And the points I want you to check is 0 and 1/2. Yeah? So let's try out the first one. 5 times 0 plus 10 times 1/2 equals 5. Okay, 5 times 0 is just 0, so that goes away. 10 times 1/2 is basically 10 divided by 2, which gives you 5. And 5 obviously equals 5. So this one works out. That's the first one. So the second one. Okay, so 22 times the 0 minus 6 times the 1/2 equals -3. Okay, so 22 times 0 goes away, so it's just 0. Now, minus 6 times 1/2 is basically 6 divided by 2, which answers 3. And equals -3. So over here we have a -3 and -3. So it's obviously also correct. Which means the point 02 is a solution for this question, for this system, right? It works out. Yes. The point 02 is a solution. Now here's a question for you. Is it the only solution? Is it possible for this system to have another solution? Yes, no, maybe. Here's how you can tell. When a system has only one solution, that means the two lines are intersecting lines. So the fact that you find one means that there's at least one, so we already know that. And the fact that the two equations are not similar, they're not the same, and you can't rewrite one in order for it to be the same as the other one, that means that this has one unique solution. This system has a one unique solution. And when a system has a one unique solution, that means that these two lines intersect. Otherwise, there won't be a point where the two equations are the same. Make sense? So, if I wanted to graph this line right here, hypothetically, let's say it's this one, right? This is the first one, and this is the second one. So, line number 1, here it is. Line number 2, here it is. Because the system gave me one point where both lines worked out, that means that their graph should intersect at that very point. Make sense? So, if I found no solution, that means that these two lines would have been parallel. They would never intersect. Therefore, there is no solution. Since I found one, they do intersect. Make sense? So, first case scenario, there is an intersection and there's only one unique solution. Second case scenario, they don't intersect, and in that case you have no solution. The system would be inconsistent, kind of like the first one. Okay? And third case scenario would be if there's infinitely many solutions. And in that case, I would have given you the exact same line. That means the graph of one line and the graph of the other fall right on top of each other. That means they intersect at every single possible point you have. Yeah? They're basically the exact same line. Make sense? So, let me show you here a few ideas and a few examples of how to solve them. Okay, so first I will write it here in the notes so you guys could copy it. It's already in my set of notes, but if you want to write it down for yourself, go ahead along with me. So, case number 1. 1 unique solution. Intersection, right? So the two lines are gonna intersect. Case number 2. I didn't write a 1 here. Okay, case number 2. No solution. Parallel. I wrote a double L for some reason. Anyway. Case number 3. Yeah? Infinitely many. So if you have infinitely many solutions, what happens in that case? That means the two lines are the exact same line. Right? Okay. Now, solution methods. There's two ways to solve a system. Because what we did so far wasn't really solving. The question gave you a point and asked you to plug it in and tell me if that point is a solution, yes or no. But what if I just gave you a system and told you to tell me what x is and what y is? You need to be able to solve the whole system by yourself without having the point beforehand. So there's two ways. First one is called substitution. And the second one is called addition. In substitution, what we do is you isolate one variable and then you substitute the value of that one variable into the other equation, and you solve an equation with only one variable. Make sense? You basically get rid of the fact that the system has two variables. Okay? For the addition, however, what we do is we manipulate the coefficients of the two variables, and we make sure that they match for at least one of the variables, so that when we add or subtract, we can get rid of that variable completely. Alright? So let me show you an example of both. Hopefully that will make more sense as we go. Okay, so here's a system, and I'm going to solve it using the substitution method. Okay, so system says 3x plus 3y. Oops, 2x, sorry. 2x plus 3y. And it equals 10. Alright? And we have 5x minus 1y, and it equals negative 26. Okay? So substitution says that I need to grab one of these two equations and rewrite it in terms of one of the variables. Which one? It's up to you. Which equation is up to you, which variable is up to you. You choose. And no matter what you choose, if you do the math correctly, you will get the right answer no matter what. Okay? So it doesn't matter which one you choose. However, there is a wise choice, and the wise choice differs based on the system. For example, for this one, you can technically grab the first one. You can set it equal to x and just move the 3y to the other side and divide by the 2. But that makes it kind of nasty, right? Same for the 3y. For the second one though, if I choose this equation and I choose to do the y instead of the x, what happens then? I'm going to move the y to this side, turns positive. Move the negative 26 to this side, which turns positive. And the y has a coefficient of 1, which means I don't need to divide by any number. So you're not going to get a fraction. You're just going to get y equals 5x plus 26. So if I rewrite this, right, negative y goes to that side, negative 26 becomes here. So it's 5x plus the 26 equals y, like that. So it looks simple, easy. We don't have any fractions. We're good. Again, if you chose to do x, it still would be correct. It would just look worse. If you chose to use the first one, x or y, again, that would still be right. This is just the simplest way. Okay? Now, I rewrote one of the equations. Now, we're gonna use the substitution part of the idea. So now that I did this, so now I'm basically telling myself that y equals 5x's plus 26. So I'm gonna go to the other equation. Never plug this into itself. Like, don't use the same equation. Use the other one. That's why you have two. Yeah? So if I use the second one to rewrite, that means I'm plugging it into the first one. If you rewrite the first one, you plug it into the second one, and so on and so forth. Okay. So, now, second equation says I have 2x plus 3y equals 10. And now we know that 1y equals this, right? So what I'm going to do is write down my first equation, which is 2x, plus 3 times y, which happens to be this. So I'm plugging the y in, like that. So I'm saying 3y is basically 3 times 5x plus 26, which is y. Make sense? And then you set the whole thing equal to 10. So this rewrite, after I plugged in this, the value of y, turned my equation into an equation where you only have x. See what happened? Now this is solvable. You can easily do this. So we have a 3 multiplied by a pair of parentheses. So that's a complication. Let's get rid of it. So I'm gonna get rid of this complication by multiplying it in. So 3 times the 5. We went to 2x real quick. 3 times the 5 is 15x. 3 times the 26 is what? 78, right? And it equals 10. Yeah? Now, these two values are x's. So 2x plus 15x is 17x. And this right here is a number, so I can move it to the opposite side, right? So 17x equals negative 78 plus 10, which is negative 68. Yeah? So divide by 17, divide by 17, and x is negative 4. That's x. If you stop here, you got half of the answer. You did all of that work and only got half of the answer. Because the other half, at this point, is really easy. Because remember, question asks you to solve the system, and the system has 2 variables, not just 1. I need to find y. Good news is, though, you don't have to do all this again. You just plug the x you have into this equation, where we have y set up. I'm going to plug the negative 4 in here and find what y is. So it's 5 times the negative 4 plus 26 equals y. So 5 times 4 is 20, and it's negative, so negative 20, right? Plus 26, so that totals to positive 6, so y is positive 6. Done. And the solution is negative 4 and 6. Okay, so that was substitution. Let me do the exact same problem, but using addition. So I hope the few seconds I just gave you were enough to pause the video and copy this. If not, do it now. Just press pause and copy it down. Anyway, here we, oops, I already used that side. Alright, here we go. Now, again, I'm going to use the exact same system. So it's 2x plus 3y equals 10. 5x minus y equals negative 26, right? And as a side note, I'm writing the answer right here to show you that both methods are going to give you the exact same solution. Okay, so this is what we got when we use substitution. Now I'm using addition. Okay? So the addition method is I need to manipulate the coefficient of one of the variables so that they cancel out. Yeah? So what I'm going to do here is I'm going to multiply the equation on the bottom by 3. And here's why. Because over here I have 3y, over here I have negative 1y. If I multiply this whole equation by 3, this becomes 15, and this becomes negative 3y, and this becomes negative 78. Right? So over here, you end up with a positive 3y and negative 3y. If I add, hence the addition, both equations, the y's are just going to cancel. And you're going to end up with x's and the answer. Make sense? Now, just like the first one, if you choose not to do this specifically, and you want to manipulate the x instead, you technically can. it's not going to be as simple, but it's going to be correct. For example, if you want to do the x, and you're like, okay, how do I make the x's cancel? Well, you have a 2 and a 5, both are prime numbers, so there's no shortcuts. You just have to multiply them by each other. So 5 and 10 multiplied, 5 and 2 multiplied, that's 10, right? So you're going to multiply the top one by 5 and multiply the bottom one by 2 to make both coefficients 10. Now, since we're adding, you want the sign of one of them to be negative. So you're going to have to multiply one of the two equations by a negative. Make sense? Now, it doesn't matter which one, as long as you do it correctly. So if you multiply this whole thing by negative, this turns positive, this turns positive, this turns negative. If you multiply this whole thing by negative, 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 negative. Make sense? And then you solve it that way. But again, the y is the easiest way. So we'll do that one. And multiply the entire thing, second equation, by 3. Yeah? So this becomes 2x plus 3y equals 10. That's my first equation. 15x minus 3y equals negative 78. This is my new second equation after I multiplied it by 3. Draw a line, addition, and here we go. Now we're adding the x's. 2x, 15x, that's 17x. 3x, negative 3x, 3y, negative 3y, that is a 0y. Positive 10 and negative 78 is negative 68. So this gives you 17x equals negative 68. Divide by 17 on both sides, and x is negative 4. And you want to see something neat? Check out the work. Over here, you see the result of the addition. 17 and 0. Negative 68. Look at the work we did. At the end, after we did all of that, we got what? 17 and negative 68. So, I don't know about you, because I've been told otherwise by other students before, but I think addition is a lot easier than substitution. But again, it's just going to depend on the system. Sometimes, I'm gonna give you a system that's basically set up for substitution, that if you want to do addition, is going to take extra work, so you might as well just do the substitution. And if I give you a question that says to use one of the two methods, you obviously have to use that one method. Okay? But if I don't, it's really your choice. So anyway, we're not done. We found x, now we need to find y. So, we have x. All you need to do is grab one of the two equations, plug x into it, and solve for y. I'm gonna grab the second one because it's easier. So we have 5 times the negative 4 minus y equals negative 26. Okay? So over here we end up with negative 20 minus y, negative 26. The entire equation is negative, so you can easily just multiply the whole thing by negative 1, but we can do that later. So I'm gonna move the 20 to this side. Negative y equals negative 26 plus 20. So negative y equals negative 6. Both negative, divide by negative 1, divide by negative 1, and y is positive 6. So the answer ends up being the point negative 4 and 6. Just like the first question. Okay? I'm gonna do this so you can see the whole thing and get a chance to copy it down. I don't know about you, but I found this section very fun. I really like it. Okay. So let me do a few more. Okay, how about number 6? Let's do number 6 together. Here you go. So the question says solve doesn't matter which one we use. So I'll show you the system, and then we'll choose what to do together. Here you go. We have 2x plus 4y equals 4. This is the first equation. Second equation is y equals 5x minus 7 over 4. Which one do you think we should use? Substitution or addition? If you thought substitution, you're right. If you thought addition, you're not wrong, it's just not the easy way. Because this one, as you can see, one of the two equations is already set up. It's ready for you to plug it in. If you want to use addition, then you're going to have to move the 5x, turn it negative, and keep this obviously. So it becomes negative 5x plus y equals negative 7 over 4. And then you can try and figure out how to solve it, having 1y here, 4y there, multiply this by negative 4, and so on and so forth. But since we're using substitution, I'm just going to plug this whole thing in here. So grabbing the first equation, which 2x, why did I put parentheses? 2x plus 4 times whatever y value we have. So y equals 5x minus 7 over 4, and the whole thing's multiplied by 4, and equals 4. So this is my equation. Okay, now I'm going to multiply the 4 into this pair of parentheses because I want to get rid of this complication. So it's 2x plus 4 times 5x, that's 20x, and 4 times the negative 7 over 4 gives you a negative 7 because it cancels out with the 4 on the bottom. And the whole thing equals 4. Yeah? Grab 7, move it to this side, and add these two. So 22x equals positive 11. So dividing by 22, dividing by 22, and x is 1/2. Alright? That's x. Now we need to find y. You plug x in here. Y equals 5 times the 1/2 minus 7 over 4. You're welcome to use your calculator, but plug it in here. 5 times the 1/2 is basically 5 over 2 because it's a multiplication. So you have 5 over 2. You can multiply by 2 top and bottom to make it 10 over 4 if you want. So subtracting the 7 over 4 from it, it gives you 3 over 4. And that's your answer for y. And the final point would be 1/2 and 3/4. Okay? Okay. Now, let's move on. How about these two? Okay, I'm gonna do number 7 now. So for this one, we have what? 3 times x minus 1 plus 10, and it equals negative y. This is the first equation. Second equation, 6 times y minus 5 equals 4x minus 28. As you can see, they're messy. We need to rewrite both. Okay, so here's the rewrite. First equation, second equation. So after they've been rewritten, they turn into this. Here's the first one. Now, 3 gets multiplied in, right? So that's 3x. And we have a negative 3 right here. Plus 10. Minus y. Okay. So then these two are obviously 7, yeah? 3x, positive 7, negative y. I'm going to move the 7 to the side and the y to the side. You end up with 3x plus 1y equals negative 7. This is my first equation. It has to be in the form x something y and then equals a number. Always. Okay? So this is the final form. Done. Now let's do the second one. Okay. Now we're doing this one. So 6 gets multiplied into this parenthesis. We get 6y minus 30, right? It equals 4x minus 28. Yeah? Now I'm going to grab the 4x and move it here. Grab a 30 and move it to the opposite side. So you end up with negative 4x plus 6y, and it equals positive 30 minus 28, which is a positive 2. And this is my second equation. Yeah? So these are the two I'm going to use now. I rewrote them. Okay. Now, let me write them on top of each other so you can see what the system would look like. Negative 4x plus 6y equals 2. Alright. Now, let's think. How do we manipulate these two to use the addition method and eliminate one of the two variables? So when I add, I want one of the two variables to disappear. Yeah? So how do I do that? The easiest way would be to multiply the y on top by 6, right? Because we have a 6 over here. So 6 on top would make both of them match. But since they're both positive, you need to turn one of them into negative. And since you're already multiplying this one, might as well multiply it by a negative. So negative 6. I'm multiplying the top equation by negative 6. And this is not the only possible way. You could turn x. You could even multiply this one by 6 and the second one by the negative. It's up to you. Okay. So after I multiply by negative 6, it becomes what? This is negative 18x, right? We have negative 6y, and it equals positive 42. And I'm going to copy the second equation exactly the same. I'm just writing a line so it's not confusing. Okay, so negative 4x plus 6y, and it equals positive 2. Okay, now we're going to add the two equations together. We have negative 18x and negative 4x. Added together is going to give you a negative 22x. Yes? Here, y's are going to cancel. That's plus a 0. And it equals 44. Yeah? Okay. Now, we have negative 22x equals positive 44. So I'm going to divide both sides by negative 22. These cancel, and x equals negative 2. That's your x. Now, I need to figure out what y is. So I'm going to grab one of the equations and plug it in. So I'll use the first one. This seems to be the easiest, right? The one we multiplied, which is 3x plus y equals negative 7. That is 3 times the negative 2 plus the y we don't know, and it equals negative 7. So 3 times negative 2 is negative 6, right? It's negative 6 plus y equals negative 7. Move this to the opposite side, and y is obviously 1. Now, we have negative 7, positive 6, the difference is going to be negative. So y is negative 1. So the point is negative 2, negative 1. Now, I wrote it next to it, hoping that maybe you could get the entire thing in one shot, but doesn't look like it's gonna happen. Alright, so here's the first half. Oops, sorry. Again, all you need is just to pause the video so you can copy Take your time. Okay, here's the second part. Make sure you can see everything. Okay. So that was number 7. Now let's do 8. Oops. Here we go. Right. So this one's going to be fun. If you remember the 3 situations I mentioned, I said if you get an answer, that means it's one unique solution and the 2 lines are intersecting lines, right? So if you get indefinite number of solutions, so infinitely many, that means that the 2 lines are exactly the same line, right? Okay, let me show you something. Over here, you have 10x minus 5y equals 30. Alright? And the second equation is y equals 2x minus 6. Now, these 2 equations are seemingly not the same. Right? They don't look the same. But one of them is set up for substitution, so I can plug it in. Let's see what happens when I plug in this y value in here. So you get what? 10x minus 5 times 2x minus 6, and it equals 30, right? Now, multiply the negative 5 in. So we have 5x. Negative 5 times 2x is negative 10x. And negative 5 times negative 6 is positive 30, equals 30. Okay? Note, we have positive 10x, negative 10x. What happens here? These add up to 0, so they cancel. And you end up with 30 equals 30. That's a problem. Also, you can move it to the other side if you want. This becomes negative. 30 minus 30 is actually 0 equals 0. And remember at the beginning of the semester when I said if you get an equation or an equality, we end up with 0 on both sides. That means there are infinitely many solutions. This is an identity. So, having found this, you didn't get a solution for x or y. You just got 0, 0. That means that these 2 are actually the exact same line. Now let's try to see it. I will rewrite it to show you that they are actually the exact same line. I was just trying to be sneaky and make it look like they're not. So, the first one is what? 5, 5, 5. They can all be divided by 5. So I'm gonna factor out a 5. It's 2x minus y equals 6. And over here, if I move the y to the side and the negative 6 to the side, it turns to 2x minus y equals 6. So all I did was give you the exact same equation twice, just multiplied one of them by 5. So it's really the same one, just multiplied by 5. So kind of like if you're trying to solve it with addition. How we multiply 1 to manipulate it, same idea. As long as you multiply the same value to every single thing in that equation, you don't change the value of the equation. So you're seeing this? So since it's the same one, answer is number equals number, they're exactly identical. 0 equals 0. This has infinitely many solutions. One of the 3 cases I mentioned at the beginning. This is the exact same one. Okay, now let's look at an example where you have no solution, like number 9. So, the question says, x plus 5 over 3y equals 1/3. See, I'm becoming a little bit more mean by the minute. Alright, the second question is 3 over 2x, yeah, plus 5 over 2y, and it equals 2. Yeah? Now, here's something I want to do just to set the problem up. I'm going to get rid of my fractions. Notice the bottom here, both denominators are 3. Here, both denominators are 2. So I'm just going to multiply the first equation by 3 and the second equation by 2. Just to simplify things, yeah? So this turns into 2x plus, oh sorry, I multiply by 3. 3x plus 5y equals 1. Yeah? And the second one becomes 3x plus y equals 4. Do you see anything weird about the system? Anything wrong with it? Nothing at all? Over here, we have what? 3x, 5y, 5y. So I'm basically telling you that the left side of both equations are exactly the same. It's the exact same value, because whatever x and y are, they're not changing, right? But the right side is 1 and 4? Is that even possible? So this right here should be a red flag. But if you still want to see it, let's multiply one of them by -1. Let's do the top one, for example. By -1. Yeah? So multiplying the top one by -1. It becomes -3x plus 5y, minus 5y equals -1. And the second one is 3x plus 5y, and it equals 4. And I'm adding. Okay, -3x plus positive 3x. 0 plus -5x plus positive 5x. Another 0, and it equals -1 plus 4, 3. So I'm basically saying that 0 is 3. Yep, doesn't make sense. So this is inconsistent, and there is no solution. Since there's no solution, that tells you that these two lines are actually what? They're parallel. Okay? These are two parallel lines. And that's why they have no solution. They will never intersect. So they can never equal each other. Yeah? So I hope this made sense. If you have any question, don't hesitate to email me. I'll be happy to answer any questions you have. Just make sure to either write down the number of the question you're asking about, or better yet, the time in the video, timestamp. Like for now, for example, now it's 43.29 seconds. So just tell me that stamp, so I would know which part of the problem you're confused about. That would help. So yeah, go back. Oh, actually, since I have you guys listening, it might be a good time to mention that your exam is going to be the weekend of the 24th, right? So I'm planning to give my Monday class the exam on Monday 27th, and my Tuesday class the exam on Tuesday the 28th of the week after next, right? So of April. But to give you guys more leeway, because I know a lot of you are working, and schedule doesn't always work out the way we want to, especially in what's going on. I always try to give you guys a little time ahead. So last time I opened the exam on Wednesday and left it open till Sunday, so I gave you 5 days. This time I'll try to do the same thing, but I'll start before instead of after, since the exam is technically supposed to be at the beginning of the week, not the end of the week. So I'll open it on the 24th and leave it open all the way to the 28th. Okay? So the exam open on Friday next week, on the 24th at midnight. So the moment it turns the 24th, the exam will be available for you guys to take, exam 3. And it will be due on the 28th at 11:59 p.m. Alright? So you have 5 days to take it. Take it whenever you'd like. You only have one attempt. And the exam is going to cover the remaining chapters, sections of chapter 3, which is 3.5 and 3.6, and all of chapter 4. And I'm gonna include inverse functions, which for the South Campus is section 2.7. So make sure you study that one as well. All right. Talk to you later.